So I'm going to go into my hypervisor environment here. I'm running a 2012 R2, and I'm recovering machines that are 2012, 2016, and even some 2019 based systems. So typically I'm going to recommend you run the recovery console on the same OS version or same OS family as what you're recovering. That's when you're dealing with cases like, the hypervisor not understanding what a VHDX is versus a VHD. If you're using older legacy, 2008 R2 or 2008 hypervisors, but pretty much anything from a 2012 through a 2019, 2020 server environment is going to be able to virtualize those other operating systems just fine. So that should not be an issue for you. If you bring up the recovery console in here, what I would suggest is you come into your current configuration. I would go into virtual disaster recovery, or well, first off, I would ensure you don't have other data sources selected. And you're only doing the virtual disaster recovery. And then of course you've got the start virtual machine after restore here and take a screenshot. I would actually uncheck that and come back out of this configuration and do a force restore. As soon as it finishes initializing and applying those changes, configure that force restore. That would apply the most recent update again. And let's see if you get a successful restore operation. If that's successful, then troubleshooting the boot may be a little bit better, a little bit easier. The boot failure could be for several reasons. It could be that the system is very large or has a higher CPU or RAM requirement than what we've configured by default. So the virtual machine that we're restoring, when we create the virtual machine the very first time, we're going to assign it with 2 gigs of RAM and 2 virtual CPU cores. We can see up here on some of my standby machines that I'm doing with virtual disaster recovery. If we come in here and we go to settings, you'll want to come in here and adjust the RAM and the CPU up here to something a little bit more along the lines of what the system would require. At minimum, probably 4 virtual CPUs, 4 gigs of RAM. But if it is a fairly CPU or memory intensive server, you may want to bump it up to 50% or 60% at least of what the production physical machine was running at. And that's going to allow it to boot faster and take its screenshot. If it's applying updates, driver changes, things like that, then those could also cause it to take longer to boot. And then if after a certain period we fail to boot, we will just ignore or abort the attempt and log the restore as a failure. So first off, look to see if a standard restore works properly, then we'll troubleshoot the boot failure process. Bump the RAM up. Once you bump the RAM back up and you've got a normal successful restore, re-enable your virtual disaster recovery testing and see how that's going to work out for you. There is a way to expand the timeout. How long does it wait before it fails the boot test, and how long does it wait at a minimum before it will try to take a screenshot of the environment? So I'm going to show you 2 troubleshooting items here that we can do to identify that. If you go into File Explorer on your hypervisor where you're running the recovery console, and we want to go into Program Files and into Recovery Console, you're going to find a config.ini file. And this config.ini file has some various settings that you can apply that would allow you to adjust the boot time. So I've got this commented out in my system right now, but you may want to take a screenshot of these and add these into your config.ini on your recovery console, and then schedule a reboot of that particular hypervisor, or at least fully stop all of the recovery console services and processes and restart them. But I would recommend a reboot after you add these. VDR VM boot delay in seconds. So I'm waiting 600 seconds before I can even look to check and see if there's a potential of a valid screenshot to capture. And then I wait, this VDR boot timeout in seconds is waiting 1200 seconds in my configuration here. And if I don't have a valid screenshot between 600 and 1200 seconds that it sees where it can snap, it's still working on unloading or updating hardware, getting ready or applying updates, those kind of things. Then after 1200 seconds, it will power off and blow away the snapshot that it created the checkpoint. and then that would show a failed boot scenario. So you may want to come in and increase the second value here from 1200 to something a little bit longer. You maybe give yourself 15, 20, 30, an hour even, potentially, if it's a rather robust system with a lot of changes and updates that you anticipate, and you don't have a lot of CPU and RAM to devote to it. But adjust those up. And this lower value, the 600 seconds I have here, this would be if you're getting a screenshot that's if it's capturing a screenshot on the loading screen. If it's capturing the screenshots a little bit too early, it needs to wait another 30 seconds, another minute, something like that before it is capturing the screenshot. You may want to bump this up to something a little bit longer. Start at 300, 500, 600 seconds, somewhere around there. And that will get you possibly closer to getting that successful boot. Obviously, you can go with a really long time here to start. If you get a black screen only, it could mean that you've set settings that are waiting too long. Sometimes those boot screens will time out or go to black now in some of the newer OS versions. So if waiting too long, you could just get a black screen because it's been too long of a process.